Hey guys, welcome to another video on crypto systems and cryptography. Today we'll talk about something called digital signatures, and it is, as its name suggests, it's something people put at the end of their message just so that others can verify whether or not it is really them who has sent the message. Because some people might commit to fraud and pretend to be another person and send some messages that try to deceive people. But with digital signatures, it's easy to verify whether or not someone actually sent the message. So, say we have Bob, and he has some public keys, NB, EB, and private key, DB. These are public, this is private. And how Bob got those numbers are, NB is a result of two primes multiplied together, and these primes don't have to be co-primes, but they do have to be distinct. And the most secure primes are usually the larger ones, but small ones would also work. And then we will have phi. Phi is basically equal to p minus 1 times q minus 1. Simple enough, right? And now Bob is going to choose an integer e such that 1 is less than e and less than phi. And also, very important thing is that the greatest common denominator of e and phi has to be 1. So e and phi are co-primes and have no other common factor except for 1. And now we need to find the secret component, which is d. D is found by finding the inverse of e mod phi. And what that means basically is that e times d is congruent to 1 mod phi. That's just the definition of inverses. And of course, 1 has to be less than d, and that has to be less than phi. Now, with those in mind, Bob can send his own digital signature. What he's going to do is, say this is his signature that he usually uses at the end of every message. He's going to raise that to dB and mod this whole thing with NB. So he sends that with the message he wants to send, and other people can check whether or not it's really him by doing this. They raise as dB all to the power of EB and then mod NB. This would indeed yield S because dB and EB are inverses. They multiply and get to 1, and that basically means S. It's a very interesting system because, dB is something only Bob knows, and he uses that as an exponent to his signature, but mod a public key. When other people checks his identity, they're going to raise this, exponent number all to his public key. Since dB and EB are inverses of each other, they multiply to get to 1 and ultimately cancel out. We know his public key, but if it wasn't him, say it was some random guy, say Fisher could send S because he knows that Bob usually sends this signature at the end of every message. He well could have powered it to DF, but if Alice checks Bob's identity by powering it to EB, it won't get to the original message. So that way Alice would know that it wasn't Bob who sent the message. Thank you guys for watching this video. If you have any questions, feel free to drop it in the comment section. Otherwise, see you in the next video.